Hey guys, in this video I'm going to show you how to make a Python program that makes a binary search. So a binary search from 0 to 100, for example, would be if you're looking for the number 25 or 26, for example. 25 we'll go with. So it splits that 100 in half and goes to 50. And then it splits that 50 in half because it hasn't found the number at 50 to 25. So once you find 25 and that's the number you're looking for, that's when the binary search is complete. But with other harder numbers, for like 3, for example, you'd go 50, 25, 12.5, 6.25, and so on, until you found 3. And that's basically how a binary search works, so I'll show you how to make that in Python. So as per usual, I'm just going to create a new file, new, and I'm going to say binary search. Now this binary search I'm going to do is without recursion, so you can do both either way. This one is specifically without, so just a heads up if you're going to try and use this for any certain project if you need recursion. So here's the program I'm going to type. Now this is going to be quite a long program, but I'll be explaining along the way. If you don't understand, you can also wait till the end of the video where I actually go through it line by line about what it actually means. So yeah, I'm going to go through that now. Okay, that's the end of the program. So as you can tell, I didn't really explain anything while typing, so I'm going to explain now before I actually run the program. So what I've done is created a function called binary search that takes a list and key as arguments. So those are the arguments that you see in the brackets next to the function binary search. So the variable start is set to 0 and end is set to the length of whatever the list will be. And then the variable start keeps track of the first element in the part of the list being searched, while end keeps track of the element one after the end of the part that's being searched. A while loop is then created that I created where it says start is less than end. So it's created that iterates as long as start is less than end. So it only runs if start is less than end. And then mid is calculated as the floor of the average of start and end. And if the element at index mid is less than key, start is set to mid plus 1. And if it is more than key, its end is set to mid. Otherwise, mid is returned as the index of the element. And then if no element is found, -1 is returned. And then it asks the user to enter a list of numbers in order. That list is split. And then it tries to look for the number that it wants searched for. So enter the number you want searched for. And then if index is less than 0, it will print that it wasn't found with a key. And if not, it will say that the number is found at whatever point. So you won't need to necessarily understand this if you're just trying to copy this program for some homework or whatever, but still. So I'm going to run binary search. Enter a list of numbers in order. 1, 2, 3, 4, 5. Input the number I want search for, 1. 1 was found at index 0. And obviously, with indexes, it starts off at 0. So, number 1 is at index 0, number 2 is at index 1, number 3 is at index 2, and so on. So, let me do a more complicated one. Run binary search. So, enter a list of numbers in order. 45, 31, 789, 1000. 654, 6540, 10,000. And now I'm going to say enter the number I want search for. 1000. That should say index 3. And 1000 was found at index 3. Now I haven't actually tried this. Let's see what happens if I enter something wrong, because I'm just intrigued to see if it could be fixed. So I'll just do 1, 2, 3, 4, 5 and enter the number I want search for. 6 isn't in there, so if I do that, 6 was not found, so that works fine. So if you like that video, make sure to leave a like and subscribe. Tell me how you enjoyed that video. Leave recommendations for other videos down below if you want, and I could probably make linear search, bubble sort and things like that in the future, so just let me know if you want to see that program. Until next video, bye.